Hi, okay, so this is the second part of the class for Monday the 11th of January. And I asked you to work by yourselves to calculate 4 factorial. And of course that's 4 by 3 by 2 by 1. And we find that that is 24. And 7 factorial, 7 by 6 by 5 by 4 by 3 by 2 by 1. Might have to use the calculator for this. 7 by 6 by 5, 4, 3, 2. Notice I don't need to type in the 1 because multiplying by 1 makes no difference. And we get 5,040. 10 factorial. I don't even want to write out all these numbers. 3, 2, 1. And that is a really big number. 3628800. So 3,628,800. Okay, I said I was going to show you how to do this on the calculator without typing in every single number. So if you have a Casio calculator, you'll be able to see that there's, in the yellow writing, I just have to find it actually, up here, okay? I'm hoping you can see that. It's above the x minus 1. So next to the log button, x minus 1, and above that, in the yellow writing, you can see x factorial. So for example, if I want to calculate 4 factorial, I do 4 and then shift x minus 1 button, and you can see the calculator, 4 exclamation mark, and that is 24. If I want to do 10 factorial, type in 10, shift button, and the x minus 1, and we get our 3,628,800. That's for the Casio. On the Sharp, you're looking for, again in the yellow writing, and it's n factorial is the notation that they use. So I believe that that is second function and the 4 key. But just check on your own calculator to be sure, and you'll be able to see that. Okay, the next thing we're going to look at is what happens if we're asked to calculate permutations, but we have some restrictions on them. So this is the third example we're going to do. I do apologize for the angle. I've ordered something which will make this a bit clearer. So this is example 3. Try and write as big as possible. You see that? Okay, there we go. Example 3. And this is a very typical type of Leaving Cert question that we might come up. The letters of the word Tuesday are arranged in a line. So the letters of the word Tuesday are arranged in a line. So kind of imagine them like Scrabble letters maybe. The first question is, how many different arrangements are possible? The second, put some restrictions on it though. How many of these begin with T and end with a vowel? So the first one is fairly straightforward. It's the kind of question that we've done before. If we count up the number of letters in Tuesday, we see that there's 1, 2, 3, 4, 5, 6, 7. So there's 7 letters in total. And for example, Tuesday is one arrangement, but also we could have Utesayd and variations like that. So from the previous examples we've done, we could have a box for each letter, and we look at how many choices we have for each of the box. Into the first one, we could put 7 letters, 6, 5, 4, 3, 2, 1. So you don't need to write out your pigeonholes like this unless you actually want to. Because when it's a straightforward question, arranging 7 different things, how many different ways can we arrange 7 different things? It is always going to be 7 factorial. And you can type that into your calculator. We actually answered it earlier. It's 5,040. So there are 5,040 different possible arrangements for the 7 letters of Tuesday. However, what about with the restrictions? We want to make sure that the arrangements all start with the letter T and all end with a vowel. So what does this mean? Can I zoom in? Zoom out a little bit. Okay, so here's my 7 boxes. Well, if they start with the letter T, then there's only one possible choice for my first box. Okay? It must be the letter T. I no longer have 7 options for this box. I only have 1. And if it ends with a vowel, well, there are 5 vowels in the alphabet, but in my word Tuesday, I only have 3 vowels. 3 vowels, and those are, zoom out again, those are U, E, and A. And the vowel is going in the last place, so I have 3 choices for the last letter. So it doesn't matter the order that I fill these in, because as you know, multiplication, it doesn't matter what order we do it in. Now, I've chosen the letters in the first spot and the letter in the last spot, which means that to fill these out here, I only have 5 remaining options. So filling those in, it's going to be 5, 4, 3, 2, 1. And you probably notice that that's 5 factorial, but you don't have to write it that way. You can do it the long way with your calculator. So this, when we calculate it out, is going to be 1 by 5 by 4 by 3 by 2 by 1 by 3. Again, the order that you do that in doesn't matter. So when we calculate that, we end up with, let's do the calculation, 5 factorial multiplied by 3, or multiplied out the long way, 360 different arrangements. So those are my 2 answers there. 360 different arrangements with those restrictions out of the possibility of 5,040. Okay, what's this got to do with probability? Well, what if we had a follow-up question like this? What is the probability that one of these arrangements starts with T and ends with a vowel? Well, remember, probability, of course. So when we're answering part 3, probability of an event is the number of matching events out of the total number of possible outcomes. I wrote the wrong thing there. Sorry, that should have been total. So the number of matching events divided by the total number of events. Miss a whiteboard. And the number of outcomes that match starting with T and ending with a vowel, we've just calculated there, is 360. And the total number of possible outcomes, we already calculated, is 5040. So it is important, of course, to put that into your calculator as a fraction, 360 over 5040, and we get 1 over 14. Okay, so that is what we do when there are restrictions. Now, I'd like to do a slightly more complicated example. I think we have time. Just change the paper. I apologize, this isn't very smoothly running, but you can let me know if you've got suggestions for things that you'd like to see done better, if I'm not writing big enough or going too fast or too slow. Just send me an email and let me know. Okay, so the fourth example we're going to do also has a restriction, but it's got an odd kind of a restriction. It's one where we have to keep certain terms together, or certain letters together. So the question is, in how many ways can the letters of the word numbers be arranged and that's part 1. And part 2, in how many of these arrangements are the letters M and B together? Okay, so there's a little bit to consider when we're doing this. The first thing is we treat M and B as a single letter. But there's something else going on. M followed by B and B followed by M are both valid arrangements where M and B are together. So whatever answer we have, we're going to have to multiply it by 2 at the end. Okay? So the reason for that is that we've got 2 choices for the first one, 1 choice for the second one, 2 factorial. Okay, so whatever answer we have, the answer will have to be multiplied. Will have to be multiplied by 2. Now I apologize, I didn't actually do the first part yet. So let's do that. Okay, so for the first part, there's no restrictions and we're just arranging the letters in numbers. 1, 2, 3, 4, 5, 6, 7 again. So there are 7 letters in numbers, which means it's going to be 7 factorial arrangements, which is 5,040. And you do have to calculate it. It won't be sufficient. You'll get partial credit if you write down 7 factorial, but you need to use your calculator and work that out as well. Okay, so for the second part then, we want M and B to be together, and I said we're going to treat it as a single letter. So we're going to treat it like 6 letters. Basically, if you imagine your pigeonholes, one of them is like a double width pigeonhole where M and B go together, or B followed by M, and that can move around to the different positions as well. So the answer, if we were arranging 6 letters, would of course be 6 by 5 by 4 by 3 by 2 by 1, or 6 factorial. And 6 factorial is 720. But remember, we're going to multiply it by 2, or by 2 factorial if you like, because M followed by B or B followed by M are legitimate outcomes there, meaning that the total arrangements in this case are 1,440. So now those are our 2 answers. Okay, that's pretty much all I want to do on permutations. And I would like to assign some homework now. So let me just put this up on the screen. I wrote it down earlier. Okay, I'm going to fill this in on Google Classroom as well, so I'll type it up. But for homework, I want you to do page 179, questions 1 to 5, very straightforward permutation questions. And I'd also like you to try page 180, questions 12 and 14, where the restrictions that are on it require you to think about it a little bit. And for tomorrow's video, I will go through the corrections of those homework. So in the old book, it's page 179 and page 180. And in the new book, it's page 314 and 315. So I'll put a screenshot of those up on Google Classroom, and I'll type in the page numbers as well. Okay, thank you very much, and I'll talk to you tomorrow. Bye.